Hey everybody, and welcome back to a brand new video. And in this part we're going to start off with where we left off. In the last video we had decided on how we are going to pick the new zombie, and whenever we will call this function, that will essentially pick a new zombie for us, and it will update the start position and it will update the active zombie index. And now we want to start using some of that information and actually start making these zombies move. Now, since this movement is going to be happening in every frame, we will naturally take care of this stuff in our update function, okay? So essentially, we will be checking, hey, is one of our, is rising, is falling variables, true? And if it is, then maybe we can do something about it. So the way we're gonna make this happen is every time, every single frame, since the update variable, the update function will run, we will essentially check for these variables. So what we can do is we can come in here and we can use an if statement and check, hey, if is rising, right? And we can say, hey, if the variable is rising is true, then we will do our logic here. That means we need to take care of the logic for the zombie moving up goes in here. So zombie moving up logic goes in here, okay? Else if, right? So else if it is falling. So if is falling is true, okay? That means all the logic while the zombie is going down goes in here. So essentially all of our falling logic or going down logic will be here. I'm going to go ahead and just enter here, okay? And lastly, what I'll do is in a situation where neither of these variables, so it's not rising, it's not falling, then what do we need to do? So that is what's going to happen. So anything else happens in here. Okay, so these are just essentially our if statements, and they will be looking at these variables and then deciding what we need to do. Okay, so now we've got some sort of a structure as to what we're trying to do. Well, when is rising is true, we want to start increasing the Y transform of our zombie. Okay, so let's say if this zombie here is our selected zombie, then if is rising is true, then we need to start increasing the Y value. We need to start increasing the Y value of this guy, okay? And what I noticed was that if I increase the Y value by, let's say, 3 units, that's how much, roughly, I thought, that it takes him to come all the way like so, okay? And we can tweak this later on, okay? So I'm going to go ahead and move this down, and we'll talk about, how we're going to do this. So, okay, so now that we have a general structure for what we're trying to do, let's look at how exactly we're going to do this. Now, in order to do this, what I'm going to do is I'm going to first of all go ahead and just for the sake of, so that we can see what's happening, I'm going to go ahead and make these public for a second, okay? And they're fine, you can leave them as public as well. And to show you how we're going to start moving them, what I'll do is I'll write a line of code. So I'm going to go in my zombies array, okay, and I'm going to say active zombie index, okay, so this right here is going to find me the zombie that is currently active, okay, and I will do a dot transform. So this is going to get me the transform of that active zombie, and then I will use a function called translate, okay? So if you hover over here, it will give you a tooltip which will explain it moves the transform in the direction and distance of the translation. So essentially, you should already have an idea. We kind of talked about this. We're going to be moving the Y position of the transform, and that is why we're using the translate function, okay? And we'll see this in action really shortly, okay? So I'm going to go ahead and close this off, and now we need to essentially put a direction as well, and then we'll see it actually move. Now, in order to make it move, what I'm going to currently do is I'm going to do vector2 dot up times time dot delta time, and don't worry, I will explain this to you, and I will use a variable called rise speed, okay? Now this variable doesn't exist yet, so we're going to go ahead and we're going to initialize this over here, okay? And what we'll do is we can test this, but for the sake of just, putting it in there right now, I'm going to go ahead and initialize this as 1, okay? okay? And this is going to be a public int, and we'll go ahead and do this as 1. Now, what does this line mean, okay? Well, before I explain this to you, let's go ahead and see what happens, if anything, okay? Now, what I'm going to do is in the start function, when the game starts, before anything happens, right, we want to pick a new zombie. So I'm going to go ahead and call this function here, okay? So at the beginning of the game, when the start function runs, this pick new zombie function will run, and this will find us an active zombie, okay? It's going to make is rising true, and when is rising is true, this line of code will happen, and this is essentially supposed to move the zombie. So first of all, let's just hit play and see if some of that actually happens, okay? So now notice this zombie is constantly moving up, and if I click on it, you can even see its transform changing. Okay, if I stop the game, if I play it again, hopefully it's going to be a different zombie that should start moving this time, and there you go. So our random generation is working, and our zombie is constantly moving up. Okay, so what's happening? How is this happening? Well, is rising is true for that specific zombie, and what it's doing is this finds that zombie, dot transform finds the transform of the active zombie, dot translate, and what we're saying is, hey, move it up in this direction, okay? Vector2.up means pointing it upwards, so move it up at this speed, okay? So if I change this rise speed, remember how we made rise speed a public variable? So now the beauty of making public variables is, for example, if I go in my manager, and if I want to increase rise speed to, let's say, 2, right? And if I now hit enter, I don't have to change the code. It's automatically going to move a lot faster. You can already see that, okay? So I'm going to go ahead and change it back to 1 for now. But anyways, and time.delta time, essentially, this is the time between that has happened, elapsed between the 2 frames, and this really helps the game become smooth. Okay, so if you have a situation where you're in your game, if you're moving a lot of objects, or if you're translating them, or if you're changing their transform values, and if there's a lot of like sort of clunkiness in your motion, that might be because you're not normalizing it for time.delta time. So this is just going to help that smooth motion between different frames, okay? So that is what's happening here. Now, of course, this was just to show you, we still need to figure out, hey, how are we going to take care of, how are we going to bring it back down, and so on and so forth, okay? So what we need to do essentially is say, hey, if it is rising, make it rise, but then after a certain amount of units, start bringing it back down, okay? All right, so the way we are going to do this is, all right, so what we can do is we can take the active zombie, right? Zombie dot or bracket active zombie index. All right, so this is the active zombie, okay? Dot transform dot position, okay? And let's look at the y position dot y, okay? And let's subtract its start position, okay? If you remember back here, when we were picking the new zombie, we were taking the initial starting position of the zombie, okay? So we will subtract the start position from its current position, all right? And what we will do, start position dot y, okay? And we will check, hey, is this greater than or equal to 3f, okay? And we will do this. So what we're doing here is we're checking, hey, if it is rising, okay, I'm going to go ahead and comment this line out for a second. If it is rising, check if the current transform, okay, the current transform of the zombie, the current y position, minus the starting y position is greater than or equal to 3f. 3f essentially means 3 units, okay? Now the way I got this number was just because I was testing and I saw that, hey, once a particular zombie goes up by 3 units roughly, right? That's essentially when we need to stop it and we need to make it start going down, okay? And you're free to find and fine tune that as well, okay? If you think, for example, if it's 3.2 or 3.3 or so on and so forth, okay? So if this value, right, if its current position is greater than 3 units higher than its starting position, then we need to start bringing it down, okay? And the way we can do that is we can say, hey, is rising is false, so it will stop coming here, right? What we can then say is falling is true, okay? Now, in the else statement for this if is, hey, if its current position is not more than 3 units higher than its starting position, then we can keep on increasing its position, and we already know how to do that. So that was that line of code here, okay? So if I save it now, what's going to happen is the zombie is going to start increasing its transform, but once it's 3 units higher than its starting position, it will stop and nothing else will happen, and we will quickly have a look and see what that looks like, okay? Also, in the meantime, the reason why I'm running this game regularly is to see if any errors pop up, okay? Look at that. So that is exactly what we wanted. It's increased 3 units up, and you know, it's kind of floating in the air, but that's just because of that number. We can tweak that number, and we can tweak the positions of our starting zombies, okay? So for example, if you feel like, hey, this particular zombie is maybe too close, or if all of them are a little bit too close, you know, you can just kind of fine tweak that and move them down, and just for good measure, we can hit play, and we can see if this looks a little bit better. And sure enough, this seems to be working. Now that it's at the highest position, we need to say, hey, at this point, is rising is false, and is falling is true, so the rest of the logic needs to go in is falling, okay? And we already have that set up here. Okay, so now that we've taken care of the rising part, we need to take care of the time when it's falling. And it's going to be very similar to what we did before, okay? So what we can do is we can find out our current zombie, okay? So I'm going to go ahead and just find the transform.y position of our current zombie, okay? And what I'm going to do is I'm going to, from its current position, I'm going to subtract the start position .y, and I'll check if it is less than or equal to 0f, then in this case, we know that the zombie is either, you know, it's either at its starting position or it's below its starting position, okay? And let me explain. Okay, so we are finding the current position of the zombie, and we will subtract from it its starting position, and if that value is a 0, right? Because if they're at the same point, that means that value should be 0. Or if the zombie has gone below its starting point, then that value will be negative. So if that value is less than or equal to 0f, then we need to stop making it fall. But if that is not the case, what we need to do is we need to make it fall, okay? So it might be a little bit confusing, but I think this will make sense once we go over this, okay? So I went ahead and I copied this line, and in this case, all we have to do is instead of making it go up, we can just make it go down. The rise speed is the same, and everything pretty much stays the same, okay? So what we're saying is when is falling becomes true, it comes here, okay? And if is falling is true, it will check, hey, is the difference between the two positions 0? If it's not, and it will not be in the beginning, then it will go in the else. And in this else statement, it will start decreasing the value of the y position. So the zombie will start going down slowly. Once the zombie is at the same position as its initial position or below that position, we need to make it stop. So we can do that, and we can say, hey, is falling is false, okay? Is rising was false, but we'll keep it false still, okay? And now we know that, okay, hey, we're good to go. So let's really quickly switch over and see what that looks like, and hopefully everything works this out? Well, I'm going to give Unity a second to load and hit play. And let's see what happens. Alright, this dude is going up, stop, going down, stop. Okay. And notice how he went down a little bit more than essentially what his initial position was. So to prevent that from happening, okay, we're going to go ahead and when he stops, right? When he stops, we need to bump him back to his start position, okay? So when is rising is false, so and is falling is false, then we come over here. So everything else that needs to happen goes here. So what I'm going to do is, just so that our zombies don't get all wonky and their starting positions get messed up, what I'm going to do is I'm going to go and find the active zombie, okay? Active zombie index dot transform. And what I'm going to do is I'm going to tell its position to be the starting position, okay? So starting position, where did it go? Starting position. Okay, so in the else statement, what I said here was simply that, hey, if it's not rising, if it's not falling, then just snap it to the starting position that we already knew that it started at. And now, since it's not rising, it's not falling, here's what we can do. We can call this pick new zombie function all over again. Okay, so I'm going to go ahead and call this function here. Okay, so if we did everything correctly, in the else statement here, it should come here, it should pick a new zombie, and then it should go and do this whole cycle again. Okay, so let's jump over and quickly make sure and see if that is working like we expected to. And let's give Unity a moment. Alright, so it's rising, and now it's falling, and it's picking a new one, and it's rising, and it's falling, and it's picking a new one. Okay, so this seems to be working as we had anticipated. We can go ahead and we can increase their rise speeds up a little bit, just to see if everything is working all right. And it seems like everything is going okay here. Okay. All right, perfect, guys. So I'm going to stop here. I think this is a really good stopping point for this video. We've got our zombies moving, and we are at a really good place. So without further ado, I will see you guys in the next video. Hey everybody, and welcome back to a brand new video. And in the last video we talked about how to get our zombies sort of kind of moving, and in this video I want to talk about the other big aspect of the game, which is actually getting player input. Okay, so I'm going to go ahead and stop this. Also, why don't I go ahead and activate my masks so they pretty much hide them, and we can go back and tweak these masks later. As you can see, the feet of the zombies and so on and so forth, so we'll tweak that later on. But what we want to do now is we want to talk about getting player input. And the way we're going to be getting player input is through a concept called array casting, okay? So we're going to see what that looks like in code, but in theory, what ray casting does is it casts this invisible ray. So if I switch over to the 3D view, and if I click on my camera, you notice how this is the forward direction of the camera. And when we talk about ray casting is going to be basically like this invisible laser beam that will be being fired from, you know, your main camera from this direction onto this screen, and it will be firing at any point in this screen here where we click. Okay, so when I click up here in the air, it's going to fire this invisible beam from the center of the camera towards that direction, and it will then see if that beam essentially collides with anything. So in this case, we will be checking, hey, did that beam hit a zombie? And if it did, then, you know, we want to do something to it. So that's kind of what the logic is like. And the way we're going to do this is we're going to go ahead and create a new script, okay? We're going to go in our scripts folder, okay? And we are going to create a new C# script, and I will call this script player input. Okay, so now that we have created our player input script, I'm going to go ahead and double click it and open it in Unity, and we'll see something familiar. I'm going to go ahead and get rid of some of these comments since we don't need them, and we'll start thinking about how we want to do this, okay? Now, first of all, since we want to be checking for input all the time, naturally we're going to be doing that in our update function, okay? So we will be constantly checking for input here, okay? And we want to map this input onto essentially our left mouse button, okay? Now the left mouse button also happens to be the touch point on a mobile device, so if you were to port this on a mobile device, it should also work and register your touch onto the screen, okay? And the way we do this is we do this by writing this line of code here. So it looks like if input dot get mouse button down, okay? And I will explain this to you in just a second. All right, and we will see this and hopefully it'll be pretty self-explanatory. So what we're doing is we're checking, hey, if, and this is like essentially Unity code for us to basically get and see if, you know, a mouse button has been clicked. So input.getMouseButton down, and 0 essentially maps to the left key, okay? So if you wanted to check for the right click, you would put in 1 over here. So we're essentially saying, hey, if the left mouse button is clicked, we want to do something, okay? So in this case, we're going to want to raycast. So we will raycast here, essentially. But before we move forward, I want to see if this is actually even working, okay? If my left click is even actually being registered, okay? So I'm going to quickly do a debug.log as we have been doing, and I will say something like mouse button pressed, and I'm going to Control S save my script, and I'm going to jump back into essentially Unity, okay? Now the thing is, even though we have you know, we've created the script and we've put in some behavior, we haven't really attached it to a game object, and therefore if you play the game right now, then it will be as if it doesn't exist. So we actually have to attach this script as a component onto one of our game objects. Now for simplicity's sake, I'm going to go ahead and just attach this onto our game manager. So I can drag and drop this on here like so, or I can also go on my game manager, I can do add component, and I can search for it. So I'm going to go ahead and search for player input, and I'm going to click here, and as you can see now it has been added, okay? So now if I play my game, I don't expect a lot of big changes, but when I click, and if I pull up my console, when I click here, anywhere in my scene, notice how it's giving me a debug line saying mouse button press, so it's essentially just reading every time that I'm pushing down my mouse button. So that is progress for us, okay? That's great news. It means that the code that we just wrote is working, okay? So we can go ahead and move forward from here, and we can talk about how we want to raycast, okay? So I'm going to go ahead and get rid of this line of code. Okay, now in order to raycast, this might seem a little bit overwhelming, but this is one of those things which I'll try and walk you through, but at the same time it's more so of convention. And so what we'll do is first of all, we'll create an array, okay? And the way you create an array in Unity is you create an array object of type array, okay? And you write camera.main.screenPointToArray input.mousePosition, okay? Now, if this sounds like absolute rocket science, let me break it down for you. We are creating an array, okay? And essentially, we are creating an array from our main camera, okay? And it's screen point to array, so it's basically converting that array into a screen point, and we are putting essentially the location of our mouse, okay? So we're telling it that, hey, I want you to create this array from the camera towards the point in the world that I am clicking on right now. So we check, hey, is the mouse button being pressed? The minute I press this mouse button, I want to create this array, which is pointing from the camera towards this position that I am currently at the exact position where my mouse is, okay? So now we have created our array, okay? We have created our array. Okay. Now we actually want to raycast it, okay? Now we actually want to check and see if it's hitting something, and so on and so forth. So the way we do that is, since this is a 2D project, we will do raycast hit 2D, we'll call it hit, and we'll use the physics engine, okay? Physics.2D.raycast, and if I come back here, and if I remove this, you can also see some of the tooltips as to what exactly it is that what exactly are the parameters. And what exactly does raycast do? So it casts a ray against the colliders in the scene. So basically what we have to do is we have to give it a position and a direction, okay? A starting position and a direction. So we've already created our ray, okay? So what we can do is we can do something like ray.origin and in the direction of the ray, okay? So what we're doing here, what does this line of code do? This line of code takes our ray, which we have created, and it says, hey, actually do the ray cast, okay? Actually shoot that ray out into the world from the starting point of the ray that we created in the direction of the ray that we created, okay? And in this variable here, it saves information about what it actually hit or it did not hit, okay? So we shoot the ray, and now the information of what actually happened is stored in this variable hit. And we can look into the hit variable and see, hey, what happened? Okay, so the way we are going to do that is we can do something like if hit.collider is not equal to null, okay? When we do hit.collider, we're basically checking the hit information that we got from our raycast, and we're saying, hey, did it hit a collider? So did it collide into anything, okay? And if hit.collider is not equal to null, it means that it did hit something, then it means that we can debug log here, and we can say, hey, debug.log, we hit something, okay? So essentially, we checked for our mouse button down, we created a ray. Using the array, we actually did a raycast. We gave it the starting point of our ray, and we gave it the direction in which our ray was going. And then we are now checking that, hey, did the raycast actually hit something? And we do that like so, okay? So what I'm gonna do is I'm gonna save. And before I jump back, I wanna emphasize the fact that this hit variable and this hit.collider checks if the raycast actually hit a collider, okay? So if I jump back into Unity right now and if I hit the play button, let's see what happens. Let's see if we get any debug messages like we expected to. So I'm clicking here, and I'm not getting any messages. And honestly, we were expecting to see something like this, right? Because if we hit something, right, if let's say, if we hit one of these zombies, we're not getting any feedback from that. And the reason why we're not getting any feedback is because we don't have any colliders in this scene. Okay, so when we shoot that ray out into the scene, we actually want to see if it hits something, but that hitting, that collision, for the collision to get detected by our physics engine, we need actual colliders in our scene, okay? So colliders are exactly what they sound like. So what we need to do is on our zombies here, I'm gonna go ahead and disable the mask for a second, and I'm gonna go on to my scene view, and let's go ahead and have a look at one of these zombies. Notice how they don't have a collider, and we can add a collider by coming here, doing add component, and we can give them a box collider 2D. The reason why we're going to be using a 2D collider is because this is a 2D game, and the reason why we can use a box collider is because we can use the box to pretty much sort of outline the shape of the zombie, okay? So notice when I click on the box collider 2D and attach this component onto my zombie, it pretty much takes the rough shape of it. I could have attached other types of components as well. So if I, instead of a box collider, if I want to do a capsule collider, I could also potentially use that, okay? And the type of collider that you would use would really very much depend on the shape of your sprite. So for example, if you have a basketball, then you might use a sphere collider, and not necessarily a box collider or a capsule collider. But I'm gonna go ahead and switch back to the box collider. Now what I'll do is I'm gonna hit play right now, and let's see. I know I disabled the masks, so if I click anywhere else, I expect the same behavior, but I know this zombie here does have a collider. So what happens if I click on him? Fair enough, look, over here in our console, we get a debug message saying we hit something, okay? Now that is exactly the sort of behavior that we wanted to see. So now when he pops up, if I click on him, we actually hit something. That's awesome. Okay, so that means our logic is working, and we're making progress. So what I'm going to do is I'm going to go ahead and select the rest of these zombies, and I'm going to go ahead and create a box collider 2D on all of them, and now as you can see, all 7 of them have a 2D collider on them. Now, let's see, what do I want to say? What I want to say though is that if I enable my mask again, okay, and granted our masks are not really well positioned, if I quickly just try and position them a little bit better like so, let's see, if I hit play now, so if this one pops up and I click on it, you know, we're getting our collision hits, but what happens when I click on the mask? We're still getting collisions, okay? And the reason why we're doing that is because once again, the masks, even though they are on top of our sprite, they don't have any collisions on them. So it's kind of like the raycast is actually going through the wall or through the mask, okay? When we talk about building 3D games or 2D games, and when we have a wall, the way we prevent a player from going through the wall is usually through the use of colliders, okay? So what we can do is very easily, we can go to our masks, we can select them all, and we can give them all 2D colliders as well. So if I go ahead and, whoops, not capsule colliders, and you can see, just by the way, since I accidentally did that, what a capsule collider would look like, right? They are actually spherical capsule colliders, and you might need them in certain situations, but we're gonna go ahead and get rid of them now. And we will add box collider 2D. Now notice how these guys are really huge and big, and that is a little bit frustrating. So what we're going to do is we have to manually change their size, because we can do that, and because the current ones that by default came with the, you know, that came default, were not really good enough for us. So I'm going to go ahead and let's see, I'm going to go ahead and remove all of them except for this one, and what I can do is I can try and change the settings here and try and find a good match. Okay, so if I look at this collider here, we can actually change the size and the offsets and so on and so forth. And in some cases, we might have to do that. Now, in the case of the zombies, we didn't have to do that. But over here, we were not as lucky. So to give you an example, if I change this offset here, then we can change it how far away it is from the x-axis and how far up and down it is. And we can also change the size of it, and so on and so forth. Okay, so what I'm going to do is I'm going to try and tweak this and try and make it so that it fits the actual essentially the mask. Okay, and the way I'm going to do this is I have some numbers here which I was testing with. So 1.47 in terms of width and 3 in terms of height seem to be working well. And the other numbers that I was looking at were minus 0.52 and the other one was 0.05. Okay, so when I used these values, it seemed to be working well. Now if I, for example, if I push this out, you can see that it fits really well, and there's also some leeway at the bottom. And if you're wondering how I got those values, I did not just make them up, I promise you. You know, I have the project open on the other screen, and I looked at the values which I had tweaked to it already. Okay, so essentially that's how I got those values. Okay, so now that I have my collider on this mask, and since all the masks are pretty much essentially the same, what I can do is I can click here and I can copy this component, okay, and then I can go ahead and select the other masks, okay, and I can come here, I can click on a star here, and I can say, let's see, I can add a, let's go ahead and add a box collider to all of them, which is going to look like this. And then I can come here and I can say paste component values, okay? When I go ahead and paste the component values, notice how they all fix in place and they all look great. Again, I'm not too bothered at this point about the exact positioning of these sort of essentially the masks and so on and so forth. We can keep tweaking that later on. And you can do that yourself as well, but now we have colliders on all our masks, okay? So, now, if I actually play the game, what's going to happen is that it will still seem the same, but actually it's now going to be hitting our masks, so it's actually hitting our masks. And you probably already guessed it, well, how do we tell the difference? between what collider in the scene it's hitting, and that is the thing that we will look at next. Okay, so our player input is coming along really well, and I think this is a really good place to pause and let everything that we've talked about sink in. And I will see you very shortly in the next video, where we will talk about how we can actually make sure that our raycasts are in fact hitting the zombies and not the masks, and so on and so forth. Okay, good job guys, and I will see you in the next video. Hey everybody, and welcome back to a brand new video. So we're gonna start off where we left off. Now, in the last video we were talking about detecting clicks and pretty much checking and seeing if we're hitting something with our raycast, and today we're going to continue building on that. And what we now need is we need a way to differentiate when we hit a game object in our hierarchy, in our scene. We want to get some information about what we actually hit. And we can do that through the use of something called tags, okay? So essentially what we can do is we can go on our game objects and we can give them a custom tag. And when we hit, when we hit the raycast, we can check if the tag that we hit matches the one that we're looking for, okay? So just to give you an example over here, earlier on we had the main camera, which came along with when we created the project. And notice over here in the tag field, it had already tagged this as main camera, okay? So because it was already tagged as a main camera, we were able to do something like camera.main and automatically have Unity know that, hey, we're talking about the main camera in this scene, okay? So just like our camera has this tag, the main camera tag, we can go ahead and tag our zombies as well. So when I go here on one of my zombies, I can click here on tag, and I can give it any of these tags, or I can create my own custom tag. And I'm going to go ahead and click this plus sign here. Now the reason why there seems to be some of these removed ones was because I was pretty much just testing and fooling around with it, but you should not necessarily have those there. I'm going to hit the tag button, and I'm going to create the enemy tag. Here, I'm just going to call it enemy. You can call it zombie, you can call it whatever. As long as you remember what you called it, you should be good, okay? So I'm going to hit save here, and it shows this tag here. If I now go back onto my zombie, notice here in this list, I can find enemy, okay? So I'm going to go ahead and select all of my zombies, and I'm going to give them the enemy tag. Again, what this does is that it helps me identify when I hit something. I can now check, hey, does the object that you hit have the enemy tag, okay? So now that we have essentially tagged the zombie, I can switch over to Visual Studios, and I can start, in this case here, I can check, hey, when we hit something, is the thing that we hit a zombie, okay? So the way we can do that is if hit.collider.tag is equal to enemy, okay? So I'm gonna go ahead and get rid of this debug line. Here's what we did. We did check if raycast hit something. Okay, so over here we did, hey, check and tell me if the hit collider is not equal to 0, okay, or if it's not null. So essentially we first did a check, hey, tell me if my raycast hit something. If it hit something, check again, hey, did it hit a collider with the tag enemy, okay? So if it hit something, tell me if it hit an enemy, okay? Now if I save this here, and let's go ahead and drop a debug line in here, and instead of saying we hit something, I'm gonna say we hit enemy, okay? Okay, so now that we've got this set, if I switch over back to Unity, then everything should run as we expect. So if I now hit the play button, we'll see what sort of behavior we get. If I hit the enemy, it should say hit enemy. And if I hit one of these masks, it should not detect anything. So if I keep clicking here, but notice how when I'm clicking here, it still seems to be detecting hits over here and what's going on over here. Okay, so the situation that's happening here is that we're shooting a raycast into the world. Okay, and I'm going to switch over to 3D view to try and explain some of this. Okay, so let's see. We have our camera, and we're shooting a raycast from our camera into these essentially game objects, okay? But the problem is that even though these game objects, let's say this zombie here, right? And if I look at this mask here, even though they both have colliders,
they're right on top of each other, okay? So because they're right on top of each other, then Unity doesn't necessarily know which collider are, they're kind of overlapping. So essentially, when you shoot the raycast, Unity is a bit confused. Hey, there's two colliders here. So what we can do to change this is we can select all of our masks, and in the third dimension, we can sort of move them here like so. Notice even if I move them up like so much in the game view, it doesn't matter because we're looking at it, in a 2D sort of a scene. But when I move it to 3D, then this is actually what it looks like. So I'm going to go ahead and move these back a little bit, even though it doesn't matter. But now these colliders that are on these masks are most definitely going to be hit before the colliders on the zombies, okay? So if I hit play now, and if I run the game and see what happens again, now when I click over here, all the way down here, it doesn't seem to be recognizing any hits, since it's not hitting anything which has the tag enemy. If the enemy pops up, and if I click on him here, it says, hey, you did hit the enemy. So things seem to be really coming along well. One thing that I noticed though was I felt like my zombies were a little bit too small. So I want to try and maybe beef them up a little bit. Let's see. So if I try and increase their scale to 1.5, 1.5, and see how that looks when I enable my mask. Hopefully they still all fit. And if I now hit play really quickly, just to test and make sure everything is working, and sure enough, things seem to be progressing. So yeah, in this video, we have so far been talking about how we can detect exactly what game object we are really hitting. You can see there's some sort of, you can kind of see the zombie a little bit, but we can fix that later. But yeah, I think this is a really good stopping point, and we will continue off in the next video.